Yo, what's up? Thank you for joining me again for another edition of OpenPair. Now, I know that at the end of the last video, I said that I was just going to go ahead and cut my losses and move forward into the next topic for my stream. But I thought about it, and I'm kind of a completionist, so you know I had to come back with a part 4. Because I really want to finish this lab, and I think that there are just a couple of more things here, and I just might as well go ahead and do them. And I was going to do them either way, but I really want to do that and share that with you, because that's a part of the journey. So, picking up where we left off, first, I want to do my announcements. You know, I always have an announcement. I always try to come with a little bit something extra every time I do this stream. So, check this out. Okay, so if you go to the resources, the links down below in the video description, like I always say, I have this resources section. Today I added 2 new links. One is a deep learning ebook that is in the form of an HTML website by one of the leading deep learning, machine learning researchers. I think he actually used to work for Apple. It's this book right here, Ian Goodfellow. He also co-wrote this book with Joshua Bengio and Aaron Corville. I don't know who those guys are, sorry. But, you know, that's neither here nor there. This is a great book. There is also an Amazon link there for you to get the physical copy as well. And I do believe there's a digital version. I know it's on Kindle, I'm not sure if it's on Apple Books. But yes, get this if you can. It's going to be a great resource. The first part of this book is specific to machine learning, so it'll go great with this video series. And then also it'll go into deep learning concepts and neural networks as well, which is a little bit more advanced, but eventually we're gonna get there as well. So that's the first link. The second link that I added here is the Deep Learning Machine Learning Notation Guide. If you struggle with mathematics, or if you see symbols and you know you kind of get a little bit lost or confused as to what is being communicated when you see this like latex notation, go to that link. So go to this this link here that says Deep Learning ML Notation Guide, and you'll be able to see this PDF. It's really a part of a GitHub repo. This is the style guide that this person uses, that Goodfellow uses in his deep learning book. But I think that this would be a great resource if you're just looking for a quick description of what the symbols and whatnot mean. Math notation is like, it's like any other language, you know. There's always going to be slight differences depending on who you talk to and depending on what institution or what person is like creating it. So this is specific to his book, but generally consistent across machine learning and deep learning. One thing you might notice is that in the stuff that I'm doing for communicating that something is a vector, I actually do the letter with an arrow above, which is more like what you would see in like traditional math and physics. The second parameter of the shape tuple, and that is the number and reference for the row, which is the element, which is the element. Okay, so and feature is another way to think about that, is column. So I'm gonna call this column. Okay, so now the next thing is, let's see here. Oh, I was going to show you how this is different from just doing a regular array. So let me make a new thing here because I'm not actually going to do this next part in code. I'm just going to let me just double check something here right quick. Just double check something right quick. Okay. So the difference between a matrix with shape 1, 1 and an array with the shape of whatever you want to call this, just nothing in there, which is what you would get if you were to call dot shape on a regular array. So you just consider this a one-dimensional array, and you can just consider this a matrix with shape 1, 1. So the difference is whenever you print this out in code, the 1, 1 array, or matrix rather, it'll be like this. It'll be like this. It'll be like this here. And then with the array, it'll be like this. Oops, forgot the other. That's the difference. And this is an important difference because if you're trying to do like matrix operations and stuff, and even if your matrix only has one column in it, I mean, that seems like that should be compatible with an array. Actually, let me go ahead and test that out before I tell you the wrong thing. I did do this before, but I could be misremembering, so I'm just gonna show it real quick, I suppose. Here, I'll take this one here. Let me print these out just to make sure. Oops. Okay, so yeah, so you can see here a matrix is this, and I'm gonna put these on separate lines, might as well. Okay, you can see here that this is my matrix and this is my array. Now you would assume that you could do something with these two. I'm going to test that out here without trying to tell you and give you the wrong answer. So we're going to call this C, or matrix and matrix array. Let's call it matrix array. So print And let me actually make, actually no, that's fine. We don't need to see numbers. So what this is doing is multiplying two zeros, so it's just gonna be 0. So this works here, doing multiplication, which is basically scaling. But what I think doesn't work is if you were to do like a dot product. I think dot product won't work. But I could be wrong. But I did try this yesterday and it was like giving me some errors. So np dot and what? Okay, wait, no. Let me go back. There was something that you couldn't do, and I remember I specifically wrote it down because what was it? Stop playing with me. No, it was something that didn't work. What was it? Maybe it was when, wait. Okay, so let me correct myself. So this will work because NumPy acknowledges that even though this is a matrix, this matrix has the same, it has the same shape as this array. But if we were to change this, let me just get this so it doesn't throw an exception. But if you were to change this here and make this matrix have two columns or two rows within this one column, then I think that would actually throw an error. So let's see. Okay, that works, but the dot product, I'm assuming that won't work. Yeah, dot product does not work unless these shapes are the same. And NumPy is smart enough to know. So what I can do is I can try, I'm gonna put this in a try, so that I don't have to comment this out. I'm just gonna literally steal this one here. Okay, so I'm gonna put this here. There we go. And let's go ahead and just toss in a new line so everything's neater. Ooh. Wait, how do I do like a blank line in print for Python? I just need like an extra empty line. No, just empty print statement, I guess. I know there's like another way to do it, but we're just gonna do that. Does that work? There we go. Okay, so yeah, so what we have here is, I'm gonna make a comment here. So if, so let's see, NumPy can perform scaling, which is what this is here. Scaling would be if you do like plus if you were to do division, well, you can't divide by 0, so it's going to give NaN, but it doesn't throw an exception. That's, I guess, what's important. Multiplying, of course, it can perform scaling on vector or vector matrix, even if the shapes are different. But Numpy cannot perform dot product if the shapes of the now wait, let me just check something real quick. What if there's more than, what if the columns don't? Okay, so Numpy cannot perform the dot product if the number of rows doesn't match. And the number of columns can be different. So the number of columns can be different. So let me rephrase this. Numpy, or for dot product, the number of columns can be different between the two. Can be different. See that can be different, but the number of rows must be the same. So for dot product, the number of columns can be different, but the number of rows can be the same. I think that is, yeah, I feel like I was gonna say one more thing. Let me take this here and give a different, or give this try accept its own version so that we keep the error here. Okay, so this is the error message you get here. It says shapes 1, 3, and 1. So this is an array. This is a matrix of 1 with 3 rows. They're not aligned. That's the error you get. So when I first saw this error here, I was super confused. And I was also streaming, so that was a little embarrassing. But yes, that's what this error here means. It means that you can have a difference in the number of columns, but the number of rows must be the same because dot product only works that way. But if you're doing scaling, which is multiplying, dividing, adding, or subtracting between two, like an array and a matrix or two matrices, then that doesn't matter. Now, another thing I want to try is what happens if we have two matrices of different sizes. Okay, the same. Oh, oops. I put curly braces. I meant to put parentheses. I'm assuming this doesn't work. Looks like it does. So you can do it with two differently shaped matrices. Okay, I'm going to capture that in its own thing, I guess. It's another nuance. Where should I put that? I'm just gonna go ahead and bring another one down here. So if I have a matrix and I have a array, or a matrix and B matrix, let's just call it that. And A matrix is 1, 3, and B matrix is 1, 2. Okay. So, let's just call this vector matrix up here. Let me edit this here. So Numpy can perform scaling, can perform dot product, I mean. Dear Lord. I'm doing like 5 things at once right now. Okay, so Numpy can perform scaling on vector matrix even if the overall shapes are different. So, 'tis true. Okay, so that is true. Let me print this here. Like this. Oops, put that in the wrong place. And oh, where'd it go? There it goes. So the scaling works even if the rows apparently don't need to be, columns are the same. Oh, I need to print this actually lower, like right here. Okay, so if the number of rows are different, scaling still works. And let me just double check that the columns are different, it still works. And it's also true and it is also true scaling can be, Numpy can prefer scaling if the number of columns are different. So I'm going to change this to 2 and change this to 1. Okay. organized so it's pretty. You know, I like a good pretty note. Is my music too loud? I feel like my music's too loud. Let me just go ahead and tone it down just a little bit. Okay. So yes, I'm just making my notes here pretty real quick, right quick. So scaling with different row sizes and scaling with different column sizes. And oh, I know what I should do. I should actually do like this. Yeah, that is a little neater. I'm just gonna go ahead and copy this whole thing. There. Column size. Love a good thorough and cute note. Okay, so for a dot product, the number of columns can be different. Here. Let me go ahead and do its own variables just for consistency here. So the number of columns can be different, but the number of rows must be the same. So I'm expecting an exception. Yes. And this right here, and let's call this B underscore matrix. Okay, that throw an exception. And matrix dot product different or different columns, same rows. Wait, this is different column or same columns, different rows. I had it backwards. Let me just put this in parentheses. Makes it a little clearer. Y'all, this is, I know this is really nitty gritty, but this is real stuff here. Okay. And I actually should take this out here, take this print statement, pop it up there, like that, and then print that out. So matrix.product, same columns, different rows. The error message you will see is shapes, so column by row. So, okay, cool. That one's done for dot product. Columns can be different, but rows must be the same. For matrix dot product, the number of columns can be different, but the number of rows must be the same. And then this last one is we're testing the same rows but different columns. I'm gonna make this 1 and then 2. And then I think I need to AB. Wait, something here is weird. I thought that would work. I'm confused now. I actually was expecting this to work. I'm just gonna act like I know what I'm doing. Don't mind me. I'm just over here in my sunglasses looking cool, you know, cool, calm, and collected. Most of all, the collected part. Okay, so oh, something I forgot is I actually printing out the wrong thing here. That needs to be that. And this needs to be here. Okay, so I guess the number of columns and the number of rows has to match for matrix dot product. So for matrix dot product, the number of rows and columns must be the same. I just feel like I'm going to do this again and I'm going to like realize that this is wrong. That's how it be sometimes though. Okay, so I'm just put a little line here to delineate. Actually, I'm going to go ahead and print this out as a thing here. I want my prints to be pretty. Or can I just do like a new line? I hate having so many different prints like that. Okay, perfect. So I'm just gonna put one up here too. Okay. Actually, I could do one right here. Okay, so yes. What I can also do to make this clearer for myself, I can get rid of this. I don't need that anymore. I can print off the shape as well. Matrix dot shape. Yeah. So the shape is, wait, did I do that wrong? Oh, forgot to put the dot shape. Okay, so you can multiplying you can scale a matrix with an array. Now, does this work if I have multiple columns? I think it does. It still works. You can scale a matrix of any size with an array, and it'll basically scale all the elements. You can scale all the elements of that matrix with an array. Okay. Array of, what if I make this into some big number or bigger number? Oh, so the reason why this is working is because this is like one number. So you cannot do it with any size array. With so you can scale a matrix with an array. Matrix with an array of size . So you can scale a matrix with an array of size, or shape, rather. And technically, yeah, technically it's an array, so I'm just gonna put here, an array of size 1, comma. So it means an array that has just one element in it. And if I change this to a matrix with just one row and one column, that would be the same thing. Whoops. Okay. An array of size of shape. I keep saying size. An array of shape 1 is considered a matrix of shape 1. Let me try something real quick. If I do 1, 0, I think that's the same. Nope, it isn't. Never mind. What if it's 1, 1? I'm getting here the impression that an array, I'm getting a sense that there's an equivalence between 1 and 1 comma and 1 1. So this is what we're getting, 1 comma, and then if I do brackets, then it's same thing. So and then so you can scale a matrix of any shape. Now I could also do just an integer. No. Okay, so I can't do an integer. I thought you could. I know you can scale a vector with an integer. So if this was this, okay. So you can't do it. You can't do it because it seems like even though the even though a matrix of shape 1, comma is similar to a vector, it's still a matrix because of how it's defined in code. As like it's like it's still considered a 2D vector, technically, even though it only has 1 column in it. It's not the same thing. So so let's see, how should I write that out here? Let me just fix this. Let me make sure this runs. Okay, so I think what we are learning here is that you cannot scale a matrix with an integer, but you can scale it with an array. Okay, so you have to scale it with, oh gosh, scale a matrix, a Numpy matrix with a Numpy array. An array, let's see that again. So you can scale it with an array, but it has to be a Numpy array. So it doesn't work with regular Python array. An array, so you cannot do this with an integer because integers do not have shape. Now I think you can, I'm pretty sure you can scale a vector with an integer, but I'm not going to do that right now because that's not really part of this, but I'm pretty sure you can do that because I think I did that somewhere up here. Let me see. Oh, we're going on an hour. I'm gonna take a break here in a few moments. Yeah, so I have an array here that's being scaled. I think it is right here. Yeah, so this is scaling arrays with integers. So that does work. Scaling with integers only works with arrays, not matrices. That's good to know. Can I scale a matrix with integer because integers do not have shape? And I'm just going to make this its own comment actually. I'll take a little break here and stuff my face with some of the burrito that I didn't finish this morning for breakfast. Okay, so I'm gonna come back after probably like 10 or 15 minutes and we're gonna just try to wrap up this little section here. We only have 3 more little code blocks to go after this. Yeah. Yeah, we only have 3 more code blocks to go after this. So yeah, I'm gonna come back and I'm gonna basically just kind of double check all of these and see if I have any more remaining questions, and then move on to the next ones. And then even if you don't choose to stay for this video, just remember that I'm going to do a summarization follow-up where I will go through all of this in one video, just straight through concisely. So remember that in my videos, I'll put in parentheses like study session or explanation. That way you know the difference. Eventually, I'll get around to making a separate playlist, you know, for study sessions and for explanations, like more tutorial style videos. But for right now, everything's kind of mixed in together. So just make sure you look at that to know what to expect in any particular video. Okay, so I'm gonna leave you just for a quick little hot second. Really, it's gonna be like 10 or 15 minutes. If you're watching this in the future, just go ahead and fast forward. If you're watching live, which I don't think anybody is, go ahead and grab a snack, get you some coffee, warm up your coffee because I know it's probably cold, and then meet me back here in a little bit, okay? So thanks, and I'll catch you in a bit. What's up? What's good? Now, I'm not trying to blame my issues on my cat, but this may or may not be the reason why I was a little bit late, because she's so cute. She's such a cute patootie. She got really hot cat breath, by the way, so I'm a little bit verklempt. Anyways, that's neither here nor there. Let's get back to this. Let's get back to this. And we're live. Okay, so where did we pick up at? By the way, how are you? How are you doing? Did you get you some coffee or some tea? I hope you did, because I sure did. I had that burrito. It's a big burrito, so it's a multi-session burrito. Okay, so back to being obsessive about matrix operations. We haven't even gotten to like the other stuff here, but let me just go ahead and review this. Okay, so Numpy can perform scaling on vector matrix if the numbers of columns are the same. Yes. Now I'm expecting if the number of ooh, excuse me. Okay, so if the number of columns are different, Numpy can perform scaling if, okay, let's see if the rows are different. Will this still work? So if the number of columns and rows are different, it can do that. Okay, so that is cool. Make sure all these are the same. Cool. Okay, so for matrix dot product, the number of rows and columns must be the same. So when there's the same number of columns but the different number of rows, we'll get an error here. And I'm going to remove this. Oops. Okay, so when the columns are the same and the rows are different, we get an error like this. And let me actually tab this over, make my formatting. You know, I love a good cute note. I love a good cute notation. I need one right here too. cube notation. So, okay, so that's what happens. I'm gonna be that crazy person and go back and add tabs to all of these so that they look good. But I'm gonna wait just a second. I'm just gonna copy this here like that. Boom, bam, shabbat bop. Boom. Okay. So when the matrix dot product uses different columns in same rows, we get this error, right? And then the same, we can inference that the same error would happen if we had different columns and different rows. So I'm just gonna make this like 3 or something. Yeah, okay. Cool. I think I can actually just do this. Perfect. 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 Okay, so let me go back and just fix my formatting on these print. There's probably an easier way to do this, but this is what we're doing today. Oh, there's my cat. What are you breaking? Okay, you just being cute. Okay, I see. I see you. I see you, baby. There was something else I needed to do. Array, oh, here. And then I'm gonna do this one here. Why does this look weird? A matrix. Looking at this one. This looks weird. I don't like the way this is formatted, but I don't think it matters necessarily. I wish I could get that all in one line, but I don't think I'm going to be able to do that. I don't think I'm gonna be able to do that, and I don't want to be sitting here trying to. I think that's fine enough. I think that is fine enough for now. Wait, where is, oh, I see what's happening. I don't need this because this is throwing an error, so this is not even going to show the contents of this. And the same, ooh, that was loud. Sorry, there's stuff going on in the background. Yeah, I can get rid of this stuff inside of this. Okay, so 1, 2, 3, there's 3, and then this here. I'm gonna break this up. Right. And I literally just said that I'm not gonna do this, and I am doing it. I'm doing the do. Mountain Dew. Okay, so I actually am more annoyed at the formatting than I need to be. Is it always going to do 2 lines for the matrix to display the matrix? You know what? I'm not even mad at myself for doing this. This is something I would probably want to know how to control. I'm just going to take a second and not even force myself to speed up. Formatting matrices in Python. Right. We're just going to look this up and see. Yeah. Yeah, I'm going to do a loop, I suppose. Because it is going to try to put each of these on a different line. One thing that might help is if I did, let me try this first. That did not help. Okay. This looks better, but I am going to, I'm going to try something else. Oh no, it's gonna be too complicated. I was gonna say I was gonna try something else, but I think I'm already like getting lost in the sauce too much. I thought it sounded like when you print in JavaScript, you can print like a table and all this other stuff that is like built into console log. I'm gonna try this. Numpy or np matrix. Matrix. Let me try this. What is that? Does that work? No, it doesn't do anything different. Okay. So, that's more pretty. That is more pretty. What if I tab that? Can I tab the entire thing over though? Oh no, it just does not want to tab both things. That is so incredibly frustrating. Tab an entire matrix Python print. I feel like literally no one cares about this. There probably is literally nothing to find to do what I wanted to do. Okay. Okay. Is there a package for printing or Python for printing matrix as table? I can do this. What if I tab that over? Does that work? It don't. Well. Huh. Very interesting. Well, I definitely learned something, which is always the goal, I guess. I'm gonna detab these, and I'm going to just put these on their own line. Yeah. Okay, so I'll do the same thing for this array as well. Yeah, I'll just have to be fine with that, I guess. I mean, that's hecka annoying. And looks like, what's going on here? Oh, output exceeds size limit. There's just too much. There's too much going on. It says that my things are too much. Where can I cut? I could probably get rid of that. Okay. Okay, well, now that I've wasted a good chunk of my lifespan doing this, we're gonna just go ahead and move on. Okay, so the next thing that we're gonna talk about or do here is, says you can manually specify data. Dimensions are specified with additional brackets matching the format of the printed above. Make a new little module here. A equals numpy array 5 comma 4 and then 3. We're gonna put all of this in brackets so that it's a matrix. And then we're gonna print off the shape of this new matrix. And then we're going to print off the array so that we can see it as well. Okay. That's fine. Okay, so that's our matrix with 3 columns that have 1 row. With matrix of 3 columns and 1 row with elements of type int 64 is what that is. Okay. And I guess the other thing, what they're saying here is that you can split these into rows or into you can put these into rows like this, which I guess this would make it more similar to what we would expect to see like in actual matrix, like if we were visualizing a matrix like in this here, make it look more like that. So if we were to do this, we could do like this, I guess. Yeah. So this will just make it easier to see. I don't think that this is normally what you're going to do, because normally you're not going to be defining your matrices explicitly. You're going to be, you know, getting it from some type of database or something like that and storing it in a data structure. But yeah, so this works as well. Okay, so now we're going to do operations on matrices. So the two indexes of a matrix n or ij rather are row column Oh, there was something above here that I wanted to put in latex as well. I'll put this one. Okay. Cagule. Okay. Okay, so we're gonna do indexing and then we're gonna do slicing and then we'll be done. So I'm just gonna title this here indexing, I guess. This will be header 4. Okay, indexing. This is gonna be similar to what we were doing before with the vectors, I guess. And let me just see, indexing with vectors. Indexing with vectors was, indexing just means a way of referring to an element by its position. So I'm gonna take that and put that in here too, just for clarity's sake. Indexing means referring to an element of a matrix by its position within the matrix. Okay. So excuse me. Setting this up here. I'm not entirely sure what this does, but we're gonna figure it out. Let me break this up because there's two things happening here. I understand what's happening here. This A range is making a array that has numbers that match the indexes from index 0 through 5, which is the first through the 6th index. But that's not apparent here unless you already know what this method A range does. So I'm gonna break that up real quick. Oops. So A reshape equals A dot reshape. Print F A So this is the actual thing that we're getting here originally. And we're going to reshape it here. Why is this different though? I feel like this is, oh, I know why. Wait. Oh, that's why. Okay. A dot reshape. There you go. Okay, so what this is doing here is np.range 6. It's making a array of size 6, and then it's just using the index to populate the value, the integer values of each of these indexes or each of these elements. And then this reshape here, this reshape is the way to, it's indexing, which means that it's taking this array and it is going to pick, it's going to basically pick entries from that array. So this -1 means it's going to start here, or wait, 0, 1. Wait, I'm confused. Reshape is a convenient way to create matrices. Well, I don't need this part. Oh, okay, so this is only the shape. Let me go ahead and print. I was getting stuck there. Okay, so a reshape here. And let me put that on a new line. And then we have a reshape is a matrix. And that is going to be a underscore reshape. So my bad. When I was looking at this here, I was like, what is this? This is actually just the shape. So this is saying this is a matrix with 3 columns and 2 rows. I think. So, okay, so this is the matrix. Okay, so we have an array with 6 indexes, numbers 0 through 5. And we're breaking this up into a matrix by going through every other or every 2 indexes here. We're going to treat as a column. I don't know what the -1 here means, to be honest with you. I don't know what that -1 is doing. Doesn't seem like it's doing much. Let's see, what does reshape do? I'll have to look that up. Numpy reshape. So the reshape, it seems like the first argument is the the first argument is the number of columns. I keep misspelling that. Second arg is number of rows. Okay. So I don't know what -1 means. Unfortunately, maybe -1 is just, I don't know, I really don't. And the shape, the matrix that is created must be able to accommodate for the available data. So the data needs to be able to be must be evenly splittable between the rows and columns. So data must be evenly splittable between rows and columns. Bow. Okay. Okay, so when you pass in, when you use -1, that is like telling NumPy that you don't know or that you are indifferent to that particular one. So what if I do -1 here, -1? Okay, so you can only specify one unknown dimension. Okay, so negative for each of the dimensions specified in .shape, .reshape, you can leave them, you can leave for only one of the dimensions specified in reshape, you can leave it undefined by passing in -1. Okay, so it'll basically only require you to give it one of these dimensions defined, and the other one can be undefined, and it'll basically figure out how to distribute that, given that the amount of data you have is able to fill that table evenly. There must be something that would allow you to accommodate for data that does not accommodate, or the data that can be split like that, but not today. Not today, sir. Thank you, but not today. Okay, so I'm gonna print New line here. Okay, so to access an element, I'm just gonna copy and paste these next two because these are just prints. These aren't actual logic. So we're just gonna copy and paste these and talk about them if they work. I need to restore this to the size that it was at before though. 6. What? Let's comment this out and make sure everything is the same here. 3, 2. It says too many indices for array. Array is one dimensional, but 2 were indexed. And oh, I know what's happening. I gotta update this because my code is a little bit different than the tutorial. Because, you know, I like to do things different apparently. So I'm just gonna change these real quick. There is a way that I could do this. Like this, I think. I can just go here, let me copy this. And I can just edit all these instances. Like that. That should, nope, that didn't fix it. Oh Lord, I did that wrong. It should be a_reshape square bracket. That should fix it. Okay, so yes, I think this needs to be on a new line. It's perfect. And we're gonna just fix this one here as well. So a_reshape and then bracket. And I'm gonna put this type on a new line. Sloppy hands. There you go. So to access an element, we're calling reshape, and then we're going to pass in a number for the column and the row that we want here. Passing in for the column and the row we want. This is going to tell us the shape. So we call .shape to get the shape of the column and row. So like, let's say that this was like an array of arrays for some crazy reason, it would give us the dimensions, but in this case it's just one dimensional. This this column number 2, which is the third column. So third column, first index, or the 0th index, which is this here. So it's a shape of this, and the value is this, which is this right here. And then this is scalar. I guess when we see these parentheses with nothing in it, that just means scalar. I should note that up here somewhere. I think I had a place where I was like doing something where I needed to know that. Where can I note that? I think I can note that right here. Cool. So yeah, that's pretty simple. It's similar to accessing an index on an array, except it's two things. I think it's still called a tuple in this case. The difference I guess here is that if you access a row, if you just pass in 1, you access the row, and that row returns, or that returns the entire row, which is going to be an array. Okay. Ooh. Oh, excuse me. Okay, our last thing that we're gonna do here is slicing, and then we're done. Oh man, this has been a good old long study session. Okay, slicing. Ooh. Okay. Let us create a new np.arrange. We're going to create a array of 20 indexes with the indexes numbered as they are. Reshape. I'm not going to split this up this time just to make it easier on myself, because I'm probably going to copy and paste some stuff here since I'm pretty tired. I'm going to print. Okay, so this is our array here. We split this into I think what I've noticed here is that when you don't tell it the number of columns to create, it looks like it's creating the least amount of columns for the data. So if I did 9, it should make 3. Or if I had, let's see, 18. No, it would make 2. If I had 9, no, it just makes 1. 15. Why is it only making 2? I'm assuming that it's just making the least amount of columns it can for the data, given that we're not passing anything. But if I did 5, 5 of 4, what if I left this -1? Would it? Oh, okay, yeah, it looks like it's taking, so it's like 20 divided by 4 is the number of columns that gets created. So number of columns equals the rows divided by range, or divided by n, or m rather. Let's call it range. So the number of columns is the row divided by the range, or the range divided by the rows, my bad. So in this case, it is 20 divided by 4 equals 10. Oh, this is not latex, this is my bad. I need to split this up, by the way, because I need my little header here. Slicing, by the way, is just, well, it's just selecting some subset of, it creates a new thing by creating some subset of the values that were in the original thing. So the matrix is creating a subset of the matrix. Okay, so yes, I'm gonna make this 10 again. Make that 10. Okay. And next thing, access 5 consecutive elements. Start, stop, step. Start means the, so based on like the array that's selected by your index that you're providing it, start means that you're taking the number of the index and you're going to count from there. Stop means where you're going to end, but is not going to include the last thing. And then step means as you're counting along that range that is provided, or that you're defining in your slicing, it's like what's your increment of counting. So you could do 2, which means every other one, or you could do 3, which means every third one. So we're going to do this to get 5 consecutive elements, which means the steps are going to be 1. So print from A, looks like this is going to be 0. 0 means that we're going to take the entire matrix. We're dealing with the entire matrix, or all of the columns in the matrix, basically. Which in this case, it's just 2 columns. And then we're taking the 0th one, which is going to be the first. So we should only be dealing with this here, with numbers 0 through 9. And then we're going to pass in the slicing, which is 2, 7, 1. And that is going to give us copy this over. So this should give us the first index of our matrix, the first column of our matrix, and it'll start counting at 2, and it'll go all the way to 7, but it won't include 7, so it'll be these, and then it'll be, so the thing that we should get back is 2, 3, 4, 5, and 6. It should be an array of 2, 3, 4, 5, 6, basically. Yep, 2, 3, 4, 5, 6. Okay, perfect. And then we want to print out the shape as well. Actually, you know what I'm gonna do is, I'm gonna keep these separate. So I'm gonna take this here and I'm gonna do dot shape on it so we can see the shape. I'm expecting this to be a shape of one, or a shape of a 1 comma, I think. Or no. Shape should be it should be 5 comma with no number, because it's 5 columns, but each of these columns are scalars. So that's basically what an array is. An array is a number of columns with scalar values instead of arrays in them, which is a little bit mind-boggling, but that's the equivalence that's being made here. So shape. What am I missing here? Okay. Equals, and then I'm gonna take this here, comma there. Yeah. So 5 comma means that this 5 comma is a way to say an array of 5 scalars. So this is similar to how I was saying before, a closed parentheses with nothing in it, that means scalar, like when it's empty. And here this just means that the second dimension here is a scalar, so it's 5 scalar values. Okay, we're going to do 5 consecutive elements in 2 rows. Okay, I'm just gonna copy this and adapt it for this next one. So access 5 consecutive elements in 2 rows. Sorry to sneeze. I need a special screen that I can switch to when I sneeze. Just specifically for that. That sounds like not a waste of time to do. In fact, it's probably the best use of time now that I'm thinking about it. I'm gonna put this on my to-do list. Anyways, excuse me. Really quickly, what I want to do is just actually, I'm not going to. Oh, let me just comment this out real quick. I want to print just the selection of the elements first, and then I'll do the other part next. So I'm going to break this up. So print a, I'm going to take this. We're going to do just the colon here, and then we're going to pass in our selection. So this means here that we're doing only the first index of our matrix. We're doing only the first column of our matrix. And then this, I'm assuming, means that we're doing this selection or this slicing for all the columns of our matrix. So we're going to be returning a matrix instead of returning an array. Oh wait, I forgot to do the thing where I actually include it. So just copy this. Oh, I forgot the bracket on this backside of that too. So yeah, I'm expecting this to give us another matrix, but the matrix is going to be sliced according to this this definition here. And it looks like it is. So yes, this matches here and this. So this is a way of slicing all the columns of a matrix to return a new matrix. And then you can just uncomment this out, change this, and make sure these are the same. Yeah, so I'm just gonna delete this one. So yes, that is giving us pure gold. And you know how we like to keep everything cute. So I'm gonna add a new line here. And I'm gonna add a new line here. Okay. Okay, so the next thing we're going to do is access all elements. So print colon dot colon colon comma colon, I mean Colin Powell. Sorry, it's a terrible joke. I have the worst jokes, by the way. If you're a subscriber, I'm just gonna let you know straight up. That's how it be. Okay, so we're gonna select the entire matrix. I kind of wonder what the purpose of this is. Let me do something here real quick. A dot shape equals okay, so yeah, I don't know like what the difference is between doing this here and just printing out a dot shape. It seems a little bit redundant, which doesn't surprise me necessarily. It is just a little bit weird, I guess. Yeah, it's just a little bit weird, that's all. Just a little bit weird. So these look the same. No cap in my wrap. So let me just go ahead and do the rest of this one. Let's make a new line, and then A colon dot shape equals A colon shape. Yeah, that is a little bit let me put a little tab there. Don't want a tab. I don't think I like that tab there. Okay, so we're getting close to being done here. We got, let's see, one more. Looks like we got one more here. So we're gonna access all elements in one row. And then that is print. One row. So we're gonna take one row of every or basically, like, it says row here, but I think what this is saying actually is the column, because remember, rows are the elements of the columns, and the columns are the elements of the matrix. I think their language might be a little bit off, but I'm gonna only do that. I'm gonna change this and fix this after I plug all this in, just to make sure, but I'm pretty sure that they're getting a mistake here, which is okay. We're gonna put a line there. So yeah, this is the second column. All X, I'm just gonna change this to column. That's what they meant to say. And that is the same as print. It's the same as this. It's the same as that. And then I'm just gonna do So this is a one-dimensional array. 1D array. Make sure that printed right. One-dimensional array. And I will actually tab this over to break it up a little bit. And then I can probably just copy this here. Sorry, got the wrong thing. This right here. So, comma, boom. I'm gonna change this, get rid of this. I think sometimes when looking at code, like there are multiple ways to do the same thing, but then like every team that I've worked on at least kind of picks a specific way of doing something, even though there are multiple ways, because some specific way is useful for like the context. So I would be curious to know, like, even if these are similar, what would be the advantage? One advantage I could see between doing it this way versus this way would be that you could pass in a variable as the second thing here. Like you could pass in, you could treat the slicing part of this as a variable that can change programmatically. Like if you were going to create some type of machine or function or some type of algorithm or utility that can like do selections based on like parameterization basically. So I could see how this way here would probably be more ideal for parameterization and making your code like more reusable versus doing your selections like this. Just based on like my experience at least. So anyways, ooh, child. Well, I think we're done. And I drank all of my tea. My wrist hurt because I've been doing this for 2.5 hours. Okay, so I'm so glad we got through this. I'm gonna come back a little bit later after I probably take a nap and relax a little bit. I'm definitely gonna take a nap. I'm gonna come back a little bit later. We're gonna talk about this, and then we'll be ready to move on to the next thing. So yeah, thank you for spending time watching this. I know these are really long, these are really intense, but like I always say, you don't, well actually I don't always say this, I'm saying it now, okay? You don't get to be awesome unless you do awesome things. You don't get to be an expert unless you get into the nitty-gritty. You won't have that fine-tuned, nuanced understanding unless you actually just dive in and get lost. So all of this is going to be really helpful in the future. We're laying a foundation. I think I said this in a couple of the videos I've done so far about how when the purpose is to study, when your goal is to learn, even if you have like guided labs like what I have here off screen, it's really important to go above and beyond when you can, if it permits. And with these asynchronous classes, you know, when you have, if you have open-ended time frame to do things in an asynchronous way, I definitely encourage you to go on those tangents and to get lost. You know, of course, always bring it back to the direction and the goal you're aiming for. But yeah, like learning the nuances of your programming language and of your tools and stuff like that is going to happen better when you do get lost, because you'll be forced to kind of be concerned with the actual details. You know, it's so easy to take an online class or a workshop or certification and to just do it and then be done and not really know what you learned, right? So by going a little bit into those tangents, asking questions, playing around beyond what you're being instructed, if time permits, you're going to get a lot more mileage, and you're going to internalize a more implicit understanding of the materials and of the course. And that's really the true goal. You know, the goal is not to complete a course. The goal isn't to get the certification. The goal isn't to, you know, have another bullet point in your resume. The goal is to actually achieve mastery and expertise. And this is how you do it. And there's no shortcut. There really isn't, you know. So, especially when you're learning a new language, like, it's not just about learning how to connect packages and pass things between packages. Like, knowing how to use a language and also what the language is doing underneath the surface and reading that documentation, that's really what your value is. That's what separates you from a script kiddie. So anyways, as always, go and check out the resources in this video, and the notes for vectorization are linked as well. I will let you know when I get these labs and everything posted, the labs and the notes posted. I have an idea about where to do that and how to do that in a way where I don't have to keep constantly updating every video individually. So just stay tuned and stay checked in. And if you are not already following, go ahead and follow for more stuff like this. And yeah, always appreciate you coming by. Thanks for being my pair programming partner today. You're lovely and smart. So I'll catch you later. My name's Key. This is Mater Development.